Hey everyone, welcome back. My name is Gladys Rama. I'm the editorial director here at Redmond Magazine. Thank you so much for sticking around for our final session of the day. This is a solution spotlight. But before we get started, a couple of quick notes. First of all, please be sure to stick around to the end, not just because you'll be able to win a $300 Best Buy gift card in a random drawing, but also because as you leave, we're going to ask you to take a very quick survey with your opinions of this event. So do give us your honest input. We read every single comment and they help us shape future summits. And speaking of future events, we really want to thank today's sponsor, A10 Networks. They're sponsoring the summit because they believe in this community and they want to back more events like it. So if you can please check out their resources in your console, visit their site, contact them for a demo, or simply ask a question during this session via the audience console. We're going to have some time at the end here for a little Q&A. But do remember that it's through A10's underwriting that we can bring you more summits like this in the future. So thanks, A10. Thanks, of course, to David and Brian for an excellent session one. And again, make sure you stay on for that prize drawing at the end. With that, I'm going to kick off this session. It's a little different. It's going to be a conversation between myself and Jameson Utter, Field CISO, at A10 Networks. Jameson, thank you so much for joining us today.
Thank you. Happy to be here.
Perfect. Now, obviously the reason we're all here today is app security. As Brian demonstrated in session one, it's a really intricate topic. It's never far from our audience's mind, no matter what their role. And API security is at the heart of it. So I'm curious, Jameson, to you, what are the biggest blind spots that IT teams have today when it comes to discovering API vulnerabilities? And are there methods that they're kind of hanging on to that are failing them in this regard?
Yeah, I would say the beginning of that blind spot is APIs in general. Typically, we find that enterprises have around 15,000 APIs in use. Let that sink in for a minute. That's 15,000. Yeah. And they typically think they have around a few hundred. And those APIs include shadow and zombie APIs, right? Which are some of those are unused APIs, meaning the product came with an API, but we didn't know it was on, right? Those are zombie APIs. And then shadow APIs are those that are happening, but you don't really realize it. Just to give you maybe a consumer example, if you have a Ring system, cameras and doorbells and stuff, that's API powered. So you may not realize that you've implemented these APIs in your company or in your place, but they're there anyway. So I think the first hurdle is getting a handle on what APIs we're using, where they're going, and what they're doing. We can't even begin to assess vulnerability until we understand that we have them.
Mm-hmm. That's a pretty alarming disconnect, going from thinking that you have only hundreds to thousands. It's like we're back in the BYOD era, but it's like, bring your own API. Now, we have a lot of security tools. I'm sure a lot of the audience here are familiar with this, but they still rely heavily on regex-based detection. First of all, I think we should define our terms. Maybe can you explain briefly what regex is? And then more pertinently, what are the limitations of it in the context of API attacks?
Yeah, so regex is a technology that sort of dates back to the early Unix days. If any of you listening are a Linux or a Unix user from the back in the day, I worked at Sun back in the glory days, so I have a long Unix background. But if we would use this command called grep, G-R-E-P, which allows us to search for things in text, it uses a regex language. And I do have a slide to show you what a regex might look like.
Oh, perfect.
And why they're difficult. Yeah, there you go.
Oh, tough. That's terrible.
Yeah, and so this is a single rule to stop a single method of SQL injection. In this case, it applies to a WAF. But again, protecting APIs is similar. Use the same sort of language to try to find something. And as you notice, it's practically incomprehensible, first of all. And secondly, it literally only applies to a string that is very specific. So when the attack is launched, there is a syntax in the HTTP request And we're trying to match that syntax with this and no other syntax, just this syntax. So what we end up with is hundreds and hundreds and hundreds of rules to catch variations of the same kind of attack. And this is just unmanageable, unwieldy, and not that useful anymore. In fact, half of the people who run regex-based systems have them turned off.
Wow. But if they were to do it, is that like something that a regular IT team is capable of doing? Or do you have to be, in your experience, an enterprise of many hundreds of IT folks to do this?
Yeah, the expertise to be sort of a regex wizard is very rare. There are some younger folks that have picked it up in the past, over time, but most of them are old gray hairs that remember the days that this was the only way to do things, right? This is 20-year-old technology applied to modern problems. And there's just entirely simpler ways. And regex is, besides its complexity, besides the limitations it has around that, another important factor is that it is based on a transaction. So each individual request coming to your API or your website is assessed individually by a series of rules. It doesn't take into account the last request made by the entity making the request or the next one. They're merely this moment, this point in time, this request. And it's just not the way attackers work today. Nobody makes one request to a website. They do probing, they do reconnaissance, and then they do a series of requests that allows them to move and pivot around the website to understand its API and what's available and how I do things. And we have to take that picture of what's occurring in real time into account when we assess whether it's a threat or not.
Right. I think now is a good time to bring up API sprawl, which sprawl of any kind is a big pain point for IT pros in general today. But API sprawl, now that's something that I feel like is talked about less. Yeah. How real is the burden of API sprawl? Is it quite common in your experience? And are there any symptoms that you can spot ahead of time to kind of curtail it? What's your take on that?
Yeah, API sprawl is a natural outgrowth of the last great visibility problem we had, which was sort of the IoT, bring your own device world. If you think about a simple example of APIs flying through your network that you probably didn't consider, everybody's iPhone that you allowed onto the network has apps on it. Every one of those apps is API powered. And then if we think about all of our automation equipment, our HVAC equipment, our cameras, our door locks, our sensors, all these things are IoT now, and they're all powered by APIs. So suddenly we have an abundance of APIs that we have no control over, right? The vendor controls the API, it's closed, aside from the APIs that our developers wrote. Typically, I find enterprises are aware of the APIs their developers wrote for interacting with their web application, but not with all of these other ones, the sprawling amount of APIs across the enterprise. So really what you have to do is get a handle on what's there. And unfortunately, the industry has focused primarily on whether the APIs are vulnerable. Well, that assumes you have access to the code base. I don't have access to the code base for the door lock. I don't have access to the camera's code base. I just have what's on the wire. And so what the industry really needed was a real-time detection system for what's happening on the wire. You can couple that with code-based security, which is great. But code-based security doesn't catch the sprawl. It doesn't catch the random rogue instances, of the conference room speakerphone, because you can't scan that API.
Mm-hmm. Right. It's the adage, you can't secure what you can't see.
That's right. Yeah. We have to detect it first to know it's there.
Exactly. And then as you established early on, it's hard to detect when you don't even know how many there are.
Right.
We have API sprawl. I think it's fair to say also we have alert sprawl or I think more commonly called alert fatigue. When you combine that with, when you combine API sprawl with alert fatigue, and just the lack of visibility into your network, when you have both of those things, what's the situation? What's the worst case scenario for organizations when they have alert fatigue on top of all that? And can we fix it?
Yes, we can. Alert fatigue comes from sort of two technologies that we have grown through in IT security. One is this rule-based system where we're throwing either positives or false positives. But typically those systems register an alert for every time a rule is hit. As I said before, nobody comes to the website and launches one command to try to get into the database. They launch thousands of them. And so those are thousands of alerts from a single transaction. Most websites are hit hundreds, if not thousands, or hundreds of thousands of times a day. So that's a snowball effect of alerts that are happening. The second thing that we did that created more unnecessary alerts is we said, we're going to fix this with machine learning. And it's going to learn what's real and what's not real and what's normal and what's not normal using machine logic. Well, the piece we didn't get there was an individual transaction is not normal or unnormal. The importance of the normalcy is what endpoint did that. So I'll give you an example here. If we see your user ID log into our website, no problem. This is every day, right? But if we see the same entity that is the one that logged in as you, log in as me, and the same entity logs again as someone else, now we know we have a problem because no entity logs in as multiple people. So that's why entity-based tracking is so important. If we're simply using machine learning, these logins are normal. They're just logins. And so it generates lots of alerts because it thinks things are wrong when they're normal, or it often thinks things are right because they're normal. And so we have to flip that machine learning on its head to get around the onslaught of alerts that are meaningless to these entities, these interactions with our website, whether they're humans or bots or whatever they are. They will develop a pattern, the entity itself, the transactions itself. And we will begin to understand now when an entity interacts with us, they log in, they typically click here, they go here, they send these commands. And now I have a holistic picture of what user interaction is behaviorally, rather than an individual interaction. So it's the pivot, right, from interaction-based to entity-based that allows us to make more meaningful, first of all, alerts, and then also to bundle them. If one of them goes crazy, I don't need to tell you 10,000 times that the same thing happened. I can tell you once, this happened and we blocked it.
Right. Yes, it'd be nice to make IT's life a bit simpler in that way. I'm just curious. Now, you mentioned a couple of times that attackers nowadays, they're sending thousands of malicious code, not just one, which of course makes it harder to track via traditional means like regex. Is that, and I'm going to get into additional questions about this topic later on, but is that related to AI nowadays? Is that something that's, yeah, you're nodding, so let's just, yeah, so is that, are they able to bypass regex more effectively now and other traditional methods because of AI?
Yeah, I don't want to give anybody any hacking advice, but you could literally, so these regex rules, by the way, are on GitHub. You can download them for your WAF. They're free. They're part of OWASP. You could literally take this regex and put it into an AI instance and ask it to write an HTTP request that this won't catch, that does a certain activity. So it can process, okay, I'll write it this way, see if it catches it, write it that way, see if it catches it. Pretty soon we have a brand new attack string. So AI has allowed semi-skilled attackers to become laser precise. It has also allowed automation of those attackers, which we always had. We always had scripts and loops and stuff like that. But to do it in a way that was far more difficult than it was previously. Previously, we could only process at the speed of a certain compute or a speed of a certain socket set, or right. We had a lot of limitations based on a 1-to-1 ratio. Now we have billions of botnets out there, devices that are compromised that can launch attacks from them. And the AI can orchestrate really complicated attack patterns that are slow sometimes, very difficult to catch when they're low threshold, fast sometimes, diversionary. Like I may launch a certain type of attack, like a DDoS attack, a volumetric against your website. What I'm actually doing is trying to get into the database over here. So I want you to look over there while I come over here. And the AI can help automate all of that in a way that's just never been done.
Yeah. And this now leads into my next question, which is probably one of my favorite questions to ask, is how have you seen the threat landscape, specifically the API threat landscape, evolve in the past few years? And I think inevitably AI will be as part of that conversation. But what kind of threats do you see becoming more common, more damaging, and perhaps not something that traditional or IT teams in general are quite prepared for?
Well, yeah, I think APIs kind of took us by surprise in a way. As we were scrambling to roll out more applications for phones and web apps and other interactions and integrating our third parties, into our operation by sending data very quickly between each other using APIs. And we rolled out all of these connected devices to help us, do conference rooms and scheduling and all these things. It didn't really occur to anybody. The first thing that occurred to them was we need to track these things. So we started to get this sort of idea of IoT discovery and that kind of stuff. But it didn't really occur to anybody about how they were talking and that might be yet another new thing. I think that lots of us thought that our traditional web security would work against APIs as well. Turns out it doesn't. Just because it's on HTTP doesn't mean that the WAF understands the context of what's happening. And so I think it kind of took us a little by surprise, because the industry around web application and API security is pretty immature overall. They're still trying to fight the fire with a 20-year-old technology, or they're trying to throw machine learning magic cookies at it, and coming up with the same results that they always got from those technologies, right? But the problem is amplified now, because how do you write a regex that works on 15,000 different APIs? You can't, right? You're going to have 15,000 versions of the same rule. So imagine them 15,000 of these to catch any type of attack that was that type for that API. Yeah. So it's a painful world that requires new thinking.
Yeah. Now, I'm going to backtrack a little bit. So you kind of alluded to machine learning a couple of times here, in a way that makes it seem like people got a little bit of a false sense of security, literally a false sense of security, because it's more of a commodity tool now. It's accessible. They think they can deploy it, and then they're ahead of the problem. Is that the case that you see, where people have this? It's not a sort of a greenwashing effect of machine learning, or excuse me, ML washing effect, but they think it may be a fix-all, but
they think it's a silver bullet. Yeah, it's not. No. I often write about AI's usefulness, which is just a new version of machine learning. Really, it's a deeper, more powerful version of machine learning, and that it's a tool. And if we use it properly and we train it properly, it can do wonderful things for us. However, lots of the startups you interact with that say we have AI now, powered by AI, are really powered by traditional machine learning, which is fine. Nothing wrong with that. It's a correct application. But the key is one, are they tracking the right data to do analysis on? Do they have enough context about what that data does or is doing or would do? And do they understand your business process? Because APIs are business process level problems. Websites are different, right? A website is a static interactive source, but APIs are influx, and everything we do in an API has to do with business process. For example, get the status of this sensor, and then apply that to this logic over here that tells us that things are too hot in the warehouse. API might say, put the status of my credit card transaction here, right? So everything is business level. We're not displaying images like websites. We're not conveying text information. We're moving components of business logic around. And so that transition is an important part of the component, in that if we just throw statistics at a machine learning instance, mm-hmm. what we get out is not necessarily that useful, right. Because it's just a bunch of data. Right. But if I can contextualize the data, have it understand the business logic, have it be part of the process, now I can create a proper filter, right? So machine learning is a powerful tool, but it's a little bit like, I think everybody's somewhat familiar with spreadsheets. It's like a spreadsheet of random data. So how do I find the anomalies in that? And are they really anomalies, or are they just the first time I've seen that command?
Yeah. And then of course you get data sprawl then, and then alert fatigue, and we're back at square one. Are there any threats that stand out to you as emerging and really notable for how effective they are and novel they are in the last couple of years, maybe specifically related to API security or not?
Yeah, I think layer 7 DDoS is a pretty new thing for us. Mm-hmm. So we were traditionally used to volumetric style attacks, network layer DDoS attacks, right? Distributed large volume terabits of data. But there's an entirely new world now with APIs where if I, for example, find out that it's costly, and I mean by costly like CPU costly, for me to load a certain page on your website, like that one takes longer than everything else. What if I sent you thousands of requests for that web page, perfectly legitimate? People go to that page all the time. Mm-hmm. From different sources. So hundreds, if not thousands of different bots are sending the request for that page. And eventually your web server runs out of CPU and crashes. That level of attack, that's a simplistic answer of what layer 7 DDoS is, but it can go further. It can be shopping carts. It can be all kinds of things. It's not a traditional sort of method of attacking. It's very sophisticated and very, very difficult to detect, because often the transaction is legitimate. Asking for that web page is just people do that. They have to. That's how we do business, right? But the implication of too many people asking for that web page is something that we haven't considered.
Right. It's true. And the scale of this, the scale of it seems to just have really escalated in the last couple of years. I'm gonna pivot a bit. So A10 acquired ThreatX recently. Can you talk about what ThreatX is, what they do, and what do they bring to the table that A10 is able to now supplement or complement existing services with?
Sure. We've really been at the front of application delivery and DDoS for more than a decade, and our position with the carriers allowed us to understand and see traffic at an entirely different level than most companies, right? At the speed and velocity. But as we've done that, we've watched cloud emerge. We've watched hybrid cloud emerge, where people have things all over and in different clouds. And to that, what we started to see was, well, we needed to do more commercial DDoS protection. We needed to do WAF. And so we started to grow the portfolio slowly through that process. But very quickly, we realized that there's more API traffic in your website than web traffic. So protecting just part of it was not as useful. Like, we're only protecting the website. What about the APIs, though? There's not really a player that is able to protect the whole picture. And that's what we wanted to do. We were trying to build a portfolio that said, we are your website's security. API, normal, DDoS, right? This is a package, a single suite of products that will protect everything. And ThreatX represented to us a paradigm shift in how to do that, first of all. That entity-based tracking is the absolute core of what allows us to do so much. And then the service that ThreatX offers, so it's not just a product, it's a service that you're buying into. We have a 24/7 SOC. They have advisors to help deal with complex, new problems or issues or whatever. And it allowed us to put all the pieces together. So you get DDoS support, you get WAP, WAF, API protection, bot protection, and all of it, again, comes from that entity-based tracking. But it allowed us to sort of to bring all of these ideas we had, all of these separate products into a single platform, deliverable as SaaS.
Right. We talked to a lot of our audience, and they comment and they email, and I think one of the bigger pain points that they have now is balancing different providers and vendors for different things. And again, I don't mean to come back to alert fatigue all the time, but it does result in a lot of alert fatigue and documentation fatigue and
right. Support call fatigue.
Yes, multiple, too many support. It's just a lot. It's a lot for them to juggle. So I think there's something there. It's quite appealing to our audience to have something holistic like that. So cool.
We see people consolidating platform all the time, trying to get fewer vendors, a tighter supply chain within their security stack. And we see our niche in that stack as protecting digital assets, right? APIs, websites. That's really our function, is to build a fully featured suite in that space to do everything. We don't do it all yet, but we're working towards all of it.
Great. Now you talked a little bit about how AI is empowering attackers to just do more, not to quote a company's very popular slogan, but to do more with less. But how is AI enhancing API threat detection and response? Like, how is AI working through specifically A10's products to meet those challenges? And again, it's not like, it's not enough just to say, you're doing machine learning, problem solved, right? Like,
right.
There has to be the intelligence part of AI has to factor into it. So how is that working in A10's, in your guys' security approach?
Yeah. So the part of the key to effective AI is most people are used to dealing with generative AI that's a generalist, right? The OpenAI, for example, ChatGPT is trained on all the data available, everything. So you can ask it to, how do I fry an omelet? And it will tell you. You can ask it, give me directions to this, and it will tell you, because it thinks it knows everything, right? Its data is the world. But the AIs that are having the most impact in industry today are trained on a specific subject, like oncology. And in fact, brain cancer, nothing else. And the models are specifically trained for that. If you ask it how to fry an egg, it says, I have no idea. I don't know anything about that. Or if you say, write me a letter about this, it goes, I can't. I don't understand that. But what I can do is if you upload an image, I can tell you where the cancer is at. That's what I know how to do. And I know how to do that in a way that is more like how human beings do it. But only when they're that specific are they able to be that effective. And they're profoundly effective when they're that specific. I have examples in a presentation I do about a company who transformed their audit process with AI. They trained a model specifically on their audit process. And they were able to do twice as many audits a day. They cost almost nothing. They take an hour to do instead of 14 days. Like, it's an incredible example of what a trained, specialized AI can do. And so that's more specifically how we are leveraging AI today, is we have one product that is able to look at traffic and then visualize what that traffic looks like by type and frequency and port and place and all that, and then build a blocking mechanism for that. So if you're being DDoS, for example, in some brand new unknown way, you put that traffic sample into there and it will tell you this is how it's happening. And then this is the rule to do that. Mm-hmm. And similarly, that applies across different areas, right? So AI, again, is not the generalist doesn't work. You have to build specific algorithms and specific data sets around types of actions. So for example, that tool can't analyze an API problem because it doesn't understand APIs, right? It just understands network layer traffic. So we're utilizing it across all of those mechanisms. We use it for research, how we understand the network of DDoS attackers on the internet. We use it for understanding the network of botnet attackers on the internet, but again, different models, right? And then we also use it and are beginning to use it more and more in the product to do real-time analysis, predictive maintenance, predictive flow, right? So the AI learns at what time of day you have more traffic and what kind of traffic that is, and how can I help shape how you're going to handle this and maybe reduce Amazon costs by doing this and that, right? It's sort of predictive network structure. Mm-hmm. And then in the future, there's many more applications that come that I can't talk about just yet.
Okay, well, we'll catch up when that happens. This is it's a really timely discussion to have, because I think a lot of the conventional wisdom nowadays around AI is that early lofty promises of ROI and effectiveness, a lot of those have left early adopters kind of disenchanted with it, and which has resulted in a lot of failed AI projects because they were general purpose AIs. And I think now the trend, as you say, is we're seeing the light about industry-specific AIs, like vertical-specific AIs, and that's, I think, where a lot of our audience and people like them will see the most return on their AI investment. So
absolutely,
yeah, it's a really good point there. And obviously, it's good to know, like AI is not the cure-all, right? There's always like a man in the middle, like need for a man in the middle security.
You should always have a human being in the loop. Yes, absolutely. Yeah. And the way I look at it is the tools we had previously are wrenches, and that made it easier for us to apply them to nuts and bolts and get things done. AI is a socket wrench. So now I have more leverage and I can more quickly do things, which means I can also more quickly do bad things or at scale do things in a bad way. So it's just a tool that we have to leverage the right way and go into it with the right expectations and guardrails and understanding of how we're going to implement it, how we're going to use it, what we expect out of it. And it's, in a way, that way, it's like a child. It's a continual training, a continual learning, like on both sides. It learns and you learn.
Right. Can I ask you about a customer disaster story? Is there, like, I'm just curious, what's the worst case? I don't know, like API sprawl or alert fatigue, or just bring your own device gone mad in an organization where A10 was immediately able to assess and corral the problem. Like, what's the nice example of A10 in action, let's say?
Yeah, I would say, typically the best horror stories that way come around things people understand. And so if we look at, I'm going to use this as an example, but it's not the actual company.
Of course. Yeah, no names.
You're trying to get tickets to Taylor Swift, right? She's coming to town. I'm going to take you and your kids or whatever to go see Taylor Swift. There's never tickets available. They're bought out instantly when they go online. And they're scalped for 2 or 3 times the price back to people. This is a huge problem, right? Taylor doesn't make any more money if it goes for $3,000 or $300. It's the same price to her, and the same thing to the venue. And they would rather see a full crowd than an expensive crowd, right? Than one that other people made a ton of money on, right? They want the venue full. In fact, the venue really wants the venue full because that's more concessions and merchandise and other things that the venue is making money on. So this problem is and again, Taylor Swift's just the example because everybody knows that. It's really difficult, right? It actually happened to Sony with the PlayStation, where people were buying massive numbers of the PlayStation 5 and then scalping them back onto the open market. So to counter that, we had to do, and again, these are not who we did it for. These are examples of how we did it for other folks just like this. Is to understand that these transactions were real, meaning they're really purchasing a ticket, but what entity launched the purchase, right? If I have 1 million different people purchasing 1 to 3 tickets, 4 tickets, this is normal. But if I have one entity purchasing 1 million tickets, this is not normal, right? So that way we are able to more accurately and efficiently understand, is the traffic reasonable or unreasonable? Even if it's not a bot, even if it's a person that clicks on the website and says, I want to buy 1 million tickets, then we're still going to see that and understand that this is out of the ordinary for these kinds of transactions. And so we need to back up and think about, do we allow this to go through? Do we not allow this to go through? Do we simply send an alert? That kind of stuff.
Right. Focus on the entity again, not just traffic trends.
Yeah, exactly.
Yeah. Looking ahead now, how is A10 evolving, or how is A10 preparing for API security threats that are yet to come? Is that even possible? And is there a way to predict these sort of things or anticipate these sort of things, or you just have to adjust on the fly? Like, what's on your roadmap?
Yeah, I don't think predicting them is something that can really be done. But what we can do is inspect them in real time, and then build behavioral models of how they're working and what they're doing, and then eventually those also become signatures, in a sense that if they do it just like this, just stop them. Don't learn again. You don't, right? You don't need to. But what we have to do is just continue to innovate around our understanding and gaining of context, because we need to understand what the APIs are doing and why they're doing them and how they're part of business logic. So to me, that's sort of the next frontier, is to be able to really link API libraries together with the external attack surface management, with enforcement points like us, right? So that you have this total picture of, from the outside, these things are vulnerable. From the API, these things are vulnerable. And then I'm controlling the movement of those traffics in the middle, right, between them. So that's kind of like, to me, that's the vision of how do we handle future API problems, is kind of the same way we're handling them today, meaning we're going to learn, we're going to understand what the entities are doing, what is their intention, and then get further into the stack, right? How do we understand business logic better? How do we understand what the purpose of the website is? Because ultimately, when you talk to security professionals, and I talk to CISOs every day, the number one priority of any executive is revenue. Number one, revenue, right? People will say CISOs care about risk and security. No, they care about revenue. They're a C-level executive in a company. Everybody in a company should care about revenue, but they do. They care about revenue first. The next thing that they really care about is time. They don't have enough time in their day, nor does their staff, to do everything they need to do, which leads to people, which is the third concern every day. Do I have enough of the right skilled people in positions to respond to this? And lastly, it's risk. That's the last thing I think about, because the three things in front of that are more important. Are we making money? Do we have time to respond to a problem? And do we have the expertise to deal with it when we get it? And so for me, that's sort of the totality of the roadmap. I can't always affect how you make money, right? Through our load balancing solutions and things like that, ultra low latency, we can help in that equation. But ultimately what I can do is help give you time back by giving you insightful, proper alerts for actual problems and enough context that it takes less skill to understand what's really wrong and how do I address it.
Right. Um, Before I get into audience Q&A, because we have a couple of questions already, I want to ask you, Jameson, is there something that you tell IT teams or businesses that you have to do this to prepare for, this is what you have to do to prepare for, to protect yourself against API-borne security attacks? Like, is there something you tell them, put this on a Post-it, stick it on your monitor, this is what you need to do?
I don't know that I really have a singular mantra, but it's kind of goes back to the, maybe I was going to say tried and true, but maybe it's more like Triton always said, you can't protect what you can't see. So the first thing you have to do is understand the problem you have. You can't start putting together regulations or GRC or other rules or whatever when you don't understand what is happening. So I have to understand what's happening first. So that's, my first thing is gain visibility and control over the APIs that are in your network. Then let's stop them from doing bad things if that's what's happening.
Right. Unacceptable to have 15,000, but only think that you only have a couple hundred or so.
Right.
Yeah. Ooh, that's rough. That's all the questions that I have, Jameson. Thanks for humoring me and answering all my questions. But we do now have some audience questions, and folks who are still on the call, do send us your questions for Jameson. Even if we don't get to it by the end of this hour, we'll make sure to pass it on to Jameson and the A10 team afterwards so they can follow up with you directly. All right, so first question here. This one's from Kurt Jameson. Kurt asks, with the vast attack surface, how do you handle third-party risk, in parentheses, vendor management, in this complex scenario?
Yeah, that's a great question. And just an example for anybody who's not quite sure what we're talking about. Think about the SolarWinds exploit that happened. That's third-party risk. Another product that you use in your network is exposed somehow because of a vulnerability they have or whatever, and they've injected that vulnerability now into your network because they're exposed. They've exposed you. And like in the SolarWinds example, what I would say is, remember, it's interacting with an API. That is how that node is working inside your network, feeding data out, bringing data in through APIs. So part of third-party risk management is to understand what are the other 13,000 APIs I'm not aware of that are in my network. Who are they talking to? What are they doing? How are they interacting? And gain control over them. So vendor sprawl is a natural part of doing business. APIs and taking on the risk of communicating with another entity, again, no choice. This is business. But what we have to do is learn how to see who we're interacting with. What are we telling them? What are they telling us? And do I have some way to stop them if something happens to them?
Right. I'm glad that you brought up the SolarWinds example, because it was such a good example of like a cottage cheese theory of security failures all around. Because from what I remember, there was one of the affected companies simply interacted with a worker from down their supply chain. That worker happened to use their work laptop and as their personal laptop, and so their machine was compromised that way, and it all just kind of spiraled out of control from there for this company. So, and of course, there's no way to vet each of your partners. So
no,
right. I mean,
no, when you open those conduits of business into your company, you have accepted the risk that company has accepted.
Mm-hmm. Yeah.
And it's a little bit like letting people sleep in your house. You're accepting the risk that this person is trustworthy or untrustworthy. Now realize that you interact with hundreds, if not thousands, of vendors in your house. There's no way you can vet everybody properly. Can't be done, right? Very different than inviting your best friends over to spend the night while they're traveling through. So to do that now, I have to have the ability to monitor, essentially, my whole home and make sure that, hands can't go under drawers and, right, people can't knock over glasses and things like that. Right? It's a very difficult situation to manage, because saying no, if you're an IT person, to business is usually your lost job, because the number one thing we have to worry about is revenue. So how do we keep that going with as little risk as we can?
Right. Yeah. No, great question. Great example. Let's see. This one here is from Jennifer. James and Jennifer asks, what approach have you seen as being helpful to customers in protecting sprawling attack surfaces introduced by hybrid cloud? Oh, yes, the the perennial hybrid cloud problem. What works?
Yeah, I think the thing that works the best there is to have a stronger consolidation of tools. So for years in IT and security, we have been told that the SIM is the end of all things, right? We're going to send everything in this giant data bucket to this thing, and it's going to solve world hunger for us. It's going to bring together and correlate all these events. And turns out it's really just a giant bucket of data that doesn't make any sense to most people because we just dump data into it. So what I'm saying or proposing is, instead of relying on yet another product to help you with yet the other problem that generates its own problems, if you consolidate your suite, so if the same products you're using in the cloud or the same products you're using in on-prem in your hybrid cloud, now at least you have one consolidated view of what is a threat, why did I think that, is it affecting both sites, right? Am I able to manage them all from one place, right? So reducing vendor sprawl and consolidating on sets of tools that are able to give me as many functions and features as possible to protect me on-prem and in the cloud.
Yeah. Perfect. And I think we have time for just one more question before we wrap up Jameson's session and we announce our drawing winner. So last question for you, Jameson, from Tim, who asks, what are the biggest attack trends you see in application security?
Oh yeah, it's certainly shifted to API. APIs by far, because it's monitored the least, it's controlled the least, and it's still really the Wild West. There's no standards for how to do API. There's no standards for any of that, right? So we're really in the infancy of API security. So attackers, again, are aware of this. And typically APIs are written to be fast, precise, and verbose. Meaning, if I have an API interacting with your company, and we are telling you we need orders, right? Every time we take an order for whatever, we send you a transaction that says, hey, one more widget, one more widget, one more widget, right? And then we ask you, when will those widgets be delivered? So we get a chunk of data that says 270 widgets were created, therefore they can be fulfilled with these orders, right? And attackers are aware of the fact that if I can learn and manipulate the API, I can just get vast amounts of questions and get vast amounts of data, sometimes in a single response. Like, give me the entire address book for your company.
Right.
Oh, here it is, right? Because the API is not smart. It's right. It's not meant to be smart. And so API attacks by far are becoming the greatest threat I've seen. And because I can affect the physical world as well, right? When I said IoT and even OT now, GE's Predix is entirely API driven. Now I can move beyond stealing things from your website or customer identities or whatever, and I can start to affect the physical world with API security, like turn your cameras off or right, do other mischievous things, and sometimes very harmful things, because I understand how to interact with this API instead of traditional web security hacks or other things.
Right. So secure your APIs. That's what we're going to end with. Just so simple. Jameson, I really appreciate you taking the time to have this conversation with us. It was super interesting. I think very useful for the folks on the call right now. So thank you for being with us today.
Yeah, thank you too. Thanks for having me.